Hi everyone, I'm Tracy Smith from Finding Physics. Today I want to talk to you about algebra basics. Before we can jump into solving mathematical equations in a physics class, we have to become more familiar with terminology. The whole purpose of the workshops that I'm doing are to try to give students the opportunity to sit back and look at different skill sets that will help them when they get into a physics class. If you are apprehensive about your algebra skills, the idea is that we're going to introduce basic terminology, symbols, notations that will make the algebra equations that you see in a physics class a little less scary and intimidating because they're not that bad. It's just understanding what everything stands for. I think that will give you a lot more confidence. So, depending on the type of physics course that you're going to be enrolled in, or maybe you're currently enrolled in, there are different amounts of algebra you may see. I know there are some physics courses that are conceptually based. And these physics classes maybe don't have a lot of math, they're talking more about the physics concepts. There are also physics courses that are all algebra. So the type of skills and terminology we're talking about today, it's a great foundation for what you would see in an algebra-based physics class. And there are also physics classes that are calculus based. That does not mean there's not algebra in them. All of these algebra skills are still used in them, but you additionally have calculus skills on top of them. So, regardless if you're in an algebra or calculus based physics class, what we're going to talk about today regarding basic terminology, this is all helpful for those classes. Okay. So, the first thing I have here, example equations. Now, I don't expect you to be able to see everything that is on the screen right here, but I do have a PDF of this that I would be downloading and giving to you for the workshop. But this is just a little smattering of different types of equations that we use in physics class. So, as we're becoming familiar with terminology, notations, I figured we should probably jump right in and use equations that are actually used in a physics class. Do not start crying right now. You do not need to know what all these equations mean at this point, of course. You do not need to even know what all these variables, and I'm going to talk a little bit more about variables, what they mean at this point. I just want to use equations that you are going to be seeing as you progress through a physics class. And like I said, this is not all inclusive, not even close. Just kind of a good little distribution of equations for us to use as we're getting familiar with different algebra skills. Okay. So let's talk about what a variable is. It's a term we use all the time and just expect people to know. A variable in physics, it's a letter or a symbol that represents something else. Just like instead of somebody calling you by your full name, they might call you by a nickname. Why? Because it's shorter and easier to reference, right? If everyone called me Tracy Lynn Smith, it would take forever every time you wanted to address me. But some people call me Trace. Hey, Trace, right? So that's much shorter. It's just a little nickname. That's what we use variables for. They're nicknames so that we don't have to say and write out big terms every time we want to address this equation. So I have a little equation here as an example. And if you take a look, terminology wise, what I have is I'm stating that the gravitational force is equal to the mass of an object times the acceleration due to gravity. So there are three separate variables I'm going to use here. I'm going to use one variable for gravitational force, and that variable is right here. It's a capital F, that's standing for force, and then there's a little g next to it. That's letting me know that the type of force is a gravitational force, and I'm going to talk a little bit more about subscripts because that's what we have there for that g and what subscripts are used for. But right here, F with that little g next to it, that stands for gravitational force. That's one variable. Then I have my equal sign, mass of the object. Well, for the mass of the object, we're simply going to use lowercase m. So now I know lowercase m means mass of the object. That's what that variable lowercase m stands for. And then acceleration due to gravity is lowercase g. So as you look at this equation, it would be a mouthful if every time I needed to reference the relationship between these three variables, if I had to say the gravitational force is equal to the mass of the object times the acceleration due to gravity. Or if you had to do a whole bunch of problems on a piece of paper and you had to write all those words out, it would take forever. It would be a waste of time. So what we do instead is we use variables. Variables, again, just symbols that are a placeholder or a nickname for some term that would be maybe a little bit more of a mouthful. So that's what a variable is. So when you're looking at all those equations on the worksheet I included, those letters, symbols, they just stand for something. And as time goes by, you're going to learn what the different variables typically stand for, and these equations are going to make a lot more sense to you. I had mentioned on the last equation that there was a subscript. We had that capital F with the lowercase g next to it. We use subscripts a lot, and the purpose of subscripts are just to give you a little bit more information about the variable. There are common subscripts that we use. So average, AVG, if you take a look over here to the right, I have AVG after the letter V, so that's telling me average velocity. And then the equation below, it's average acceleration. So AVG is telling us it's an average value. Sometimes instead of AVG for average, what they'll do is they'll put a little line above the variables that they're talking about, and that also will stand for your average value. But when we're dealing with subscripts, we usually just have the AVG, and that's telling us that we're looking at an average value. So that's one type of subscript that shows up a lot. Other types of subscripts that show up a lot are F for final. So if you take a look in this last equation here, it says VF. That's telling us that we're referencing a final velocity. If you take a look in the equation as well, there's a V with an I. That means we're looking at the initial velocity. Now, depending on your course, okay, this can be a little confusing. Depending on what class you're in, sometimes we use different subscripts to mean different things or different variables. As you get into your physics course, you'll become familiar with what your teacher or your course typically uses. For example, some textbooks use a lowercase I to stand for initial, where other textbooks, instead of lowercase I, they might use a lowercase o. And some people will say, that lowercase o stands for original. So which one does your teacher use? That just ends up being the one that you use. Once you take enough physics classes, you realize that you're switching in between these terms. But as long as you understand what they mean, it's not a big deal if somebody uses a lowercase I and somebody uses a lowercase o. So the other things that we need to look at is that the subscripts, besides average, finals, and initials, we also might have things like on the previous slide, how there was a lowercase g to stand for gravitational. So in general, subscripts are just giving you a little bit more information about a variable, but it's all still one variable. So it's just subscripts are just meaning that it's part of that letter that's in front of it, just giving you a little bit more information. Okay, this is always a favorite of everyone. Capitals versus lowercase letters. Now, I know that when we're doing our regular alphabet in the English language, that a capital V and a lowercase v mean V. So in your head, they mean the same thing. Not in physics class. And the crazier part is, not only is a lowercase v and a capital V variables that mean two different things, but sometimes, unfortunately, a capital V may be multiple things depending on what course you're in. Let me give you some examples here. A capital V stands for volume in a lot of the equations. Capital V stands for volume, but if you're doing a course on electricity and magnetism, a capital V is not standing for volume. A capital V is actually standing for potential difference. So capital V, again, depending on the type of equation you're using, it can mean different things. Lowercase v typically stands for velocity. So capital V, lowercase v, two completely different things. If we go down here and we look at capital E versus lowercase e, two different things there. Capital E, sometimes courses use that to stand for energy in an equation. Sometimes if you're in an electricity and magnetism section of your course, capital E stands for electric field strength. So again, kind of knowing the equation and what you're using it for, you can kind of decipher, is a capital E mean energy here, or does it mean electric field strength? Folks, this is why it's fantastic when you have courses like AP physics class courses and IB physics courses that give you equation sheets. But if you don't know what the equations mean, they're not helpful. You need to know, what does that capital E mean? Is that energy? Or is that electric field strength? So there's a lot you need to know. You can't just take things and expect them to work for you. Lowercase e stands for elementary charge. So the charge of an electron. A lot of times we use lowercase e. What do I have over here? Capital P versus lowercase p. So capital P, power. All right. That's something that we use a lot. And then for lowercase p, momentum. Depending on the course that you're in, pressure is another P, and sometimes I've seen it as capital in some books and lowercase in the other. But you can see that these variables, a capital versus a lowercase, two different things. And of course, I have another one down here, capital T versus lowercase t, where capital T refers to a period, which is the time it takes for maybe something to go through one cycle. If something's moving in a circle, one time to go around the circle, that we call that period. And lowercase t is just general time. So we have all of these examples here where a capital letter and a lowercase letter mean two completely different things. So don't think that capital and lowercases are standing for the same thing. They are their own variables. We have so many equations, and I already told you we're double using letters, capital letters or lowercase letters. We don't just use the English alphabet. We also use the Greek alphabet, the Russian alphabet. We take symbols, letters from different places and use them as variables for different things in physics class. And so being familiar with the Greek alphabet is so handy. I always tell my students, at the very least, I'm getting you ready for colleges so you can find your ways around sororities and fraternities. Just learn the Greek alphabet. It is very helpful to be familiar with. And there are some Greek letters that we use a lot, and there are two that I'm going to point out right now because they're used really frequently and they mean the same thing wherever you see them. So the first letter I want to talk about is the Greek letter capital delta. Okay, this is used so much in physics class. Delta means change in when we use it. So if we see delta, delta is equal to change in. What does that mean? That means take the final thing minus the initial. So if I look in this equation here, I have a delta x in the numerator and a delta t in the denominator. So what this equation is really saying, remember I told you AVG means average. This is saying the average velocity is equal to the change in x, or the change in position. What does that mean? That means take the final position, so see how I put the little f, the subscript for final, minus the initial position. That little I there standing for initial. So delta x is the same as saying xf minus xi. It's the change in the x's. So I'm sure you can guess, in the denominator, there's a delta t. That means the change in time. So we're going to take, instead of writing delta t, I'm going to take the final time minus the initial time. So that capital delta you will see all year through a physics course, and it means change in. Okay, always the final thing minus the initial thing. Okay, the other Greek letter I wanted to point out today that's very helpful is the capital letter sigma. Okay, the capital letter sigma. The capital letter sigma means the sum of. Okay, so sigma is equal to the sum of. Okay, so if I take a look at this equation right here, we have the sigma in front of a capital F. So that is telling me I want to take the sum of all of the forces. So another way that I might write that, instead of saying sigma F, I could write, how many forces are there? Maybe there's force 1 plus force 2 plus force 3. That would be put in the place of the sum of the forces. So there, to be honest, I could talk about every single Greek letter here, the capital and the lowercase, and what it stands for in physics class, but it isn't appropriate to do that now. Delta and sigma are the two that you are going to use time and time again, and I think they're helpful ones just to kind of expose you to now. If you want to get up on your Greek letters, you could do that, right? You could start looking at them and kind of saying, okay, beta, I see this is beta here, and become familiar with what beta is. A lot of you know pi. This is the Greek letter rho, just to maybe become familiar with them, because as your year goes through in physics, they're going to be popping up, and you always feel a little better when you're like, oh, I know, that's that Greek letter. What was that weird looking thing that kind of looked like a P, but it's not a P? Oh, yeah, that's rho. So kind of becoming familiar with the Greek alphabet is helpful here at the beginning of the year. Okay. We're talking algebra. We're getting closer to solving problems here. You need to be familiar with the order of operations when you're doing math. I found this very helpful worksheet online that reminds you of how you follow the order of operations when you're solving a math problem. And a lot of people use that, please excuse my dear Aunt Sally, to help remember it. But the order we go is we do parentheses, what's in the parentheses first. Then we do exponents, multiplication, division, addition, and subtraction. And there's a little example at the bottom of the screen there of how this might play out in a problem. If you were given a problem, it has 8 minus 3 plus 2 times 4 raised to the second power times 2 minus 1 plus 6. And it kind of shows you how you would break this down and go through it in the right order. Well, here's the big deal. When we're trying to solve for a variable in an equation for a physics class, and folks, we do this almost every day. I feel like saying every day. You need to realize that we actually do the order of operations backwards, because we're trying to isolate a variable. We're not going through and calculating a number like we're showing here in this sheet. What we're doing is we're going and we're working backwards, and we're trying to isolate a variable. So in order to rearrange the equation, we actually go through subtraction and addition and move things away that way first. Then we use the division and multiplication, and then we do exponents and parentheses. So this is how we make our way through algebraic equations, and we're going to do so much practice with this, folks. And I just want to kind of reference this so you know where we're getting the order of the right way of doing it. So what am I to expect in my algebra class? What's going to get thrown at me here for physics and algebra? The first thing I'm going to tell you is don't worry. Don't stress about it, folks. It is going to be okay. That sheet that I showed on the very first slide, if you can look at any equation there and pick a variable and solve for it, you're golden. You're in good shape. That's all you're doing all year is you're going to have equations, and you're going to be like, okay, I need to rearrange this equation to solve for this variable because that's the thing I don't know. Now, there are a lot of spots that people get confused and are common mistake areas, and that's what I want to go over in my workshop. So if you take a look at my little bullet point down here, what is it that we're going to do in the Algebra Skills Workshop with Finding Physics? We're going to take a bunch of those equations from the equation sheet at the beginning of this little presentation, and we are going to solve for different variables. And because I've been doing this for so many years, what I'm going to do is I'm going to show you spots where students typically make mistakes. And then you're going to learn from it now so you don't make the mistake later. Okay, that's the big idea. And guys, we're all going to make mistakes. I don't want you to get upset. Make the mistakes. That's how we learn. Typically, if you make a mistake, you're not going to make that same mistake again. You're going to learn from it and move on. So use this time to try to learn some of these typical algebra mistakes, the kind of tricky parts that a lot of students have, and then you're going to be good as you go through your physics course. So if you need more help, you want to work through these different algebra skills, you can go to findphysics.com. There you could sign up for one-on-one tutoring sessions, small group tutoring sessions, workshops like the algebra workshop that I will do in relation to this mini lesson, and different tips and inspiration through my blog and podcast. All right, everyone, I hope you have a great day and talk to you soon.